I also want us to look at fair or unfair games, games of chance. Now, a game is said to be fair if the expected value after considering the cost is zero. Yeah. If this value is positive, then the game is in your favor. And if this value is negative, then the game is not in your favor. And we'll look at that when we work out through these examples. So the first example here is in a game of chance, a player spins a square spinner labeled 1, 2, 3, and 4. The player wins the amount of money shown in the table below, depending on which number comes up. So the first question is um, determine the expected return for one spin of the spinner. Now, obviously, if you look at this table, we don't have the probabilities. So maybe the first thing that we need to do is to prepare the probability distribution table. Yeah. So let's prepare the probability distribution table for this. So here we have the number. So let me just say number, which will be, let's say that is our x in this case. The values that x can take, let me just use the smaller x. And the values that x can take in this spinner is 1, 2, 3, and 4. All right. So, and then of course, we can get the corresponding probabilities for each of these values, which is just a quarter in each case, so quarter. And then we have something else that we want to add to this table, which is called the winnings. Yeah. So we have the winnings. Oops. Didn't want to delete everything. So winnings. So we have the winnings. And here we have $1, $2, we have $5, and we have $8. Okay, so part A of this question, they're asking us to find the expected return. Expected return is like the expected winnings. Yeah? So expected return is like the expected winnings. So that will be equal to basically a quarter multiplied by $1 plus a quarter multiplied by $2 plus a quarter multiplied by $5 plus a quarter multiplied by $8, and this will be equal to 4. Yeah, so $4. So in one spin of this game, you expect to basically a return of expected winnings of $4. Now, part B of this question, they're asking us to determine the expected gain of the player if it costs 4 to play the game. So, of course, the expected return is 4. Yeah? So, the expected gain here, expected gain will be the expected return, which is 4. So 4 minus how much you're going to pay for that game, because the game costs 5. Yeah, and you can see here that we'll end up with negative $1. So basically, you're going to lose in this game. Yeah, the average expected winning is $4. You pay $5, you expect to lose $1. Yeah. Now, the part C of this question, we expected to determine whether you would recommend this, uh, whether you would recommend playing this game. Of course, you won't, because the game is just not fair. So, part C, we can say, um, since the expected gain is not equal to 0, the game is not fair. Since the expected gain is not equal to 0, the game is not fair. All right. So here's another example. Tom tosses 3 fair coins. He wins $9 if he gets 3 heads, 5 if he gets 2 heads, and $2 if he gets 1 head. If he doesn't get any heads, he pays 30. Is this game fair? So first of all, let's prepare our sample space. So 3 heads tossed. How does this look like? So possible outcomes, you can get head, head, head. You can get head, head, tail. Or you can get head, tail, head. You can get head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. Tail, tail, tail. So possible outcomes 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, seems like um, the random variable here is head. So we can say let A be the number of heads obtained. Yeah, because if he gets 3 heads, he gets that. If he gets 2 heads, if he gets 1 head. So yeah, this is what our focus is on. So let A be the number of heads obtained. Anyway, so what we need to do here is to prepare a table, probability distribution table, for what's going on here. So I'm just gonna plug in the 3 columns. So instead of so we have A probability. Oops, actually go back. So we have A here, probability A is equals to A, and then here we have the winnings. Yeah. So we have 0 here. We have 1. We have 2. And we have 3. Yeah. So these are just the values, well, the number of heads obtained. Yeah. So the number of heads will help us, of course, to get the probabilities. And then once we get the probabilities, we can use that to find the expected gain here. So anyway, back here we have the probabilities of these guys. 0 heads will be 1 over 8. 1 head from the sample space is 3 over 8. And then here we have 3 over 8 and 1 over 8. Expected winnings doesn't get any head, pays 30, so minus 30. Here you win $2, 5, and 9. Okay, so the expected gain of a player here, yeah, so the expected gain will be, obviously, here looking at the probabilities and the winnings, yeah, so 1 over 8 multiplied by negative 30 plus 3 over 8 multiplied by 2 plus 3 over 8 multiplied by 5 plus 1 over 8 multiplied by 9. And of course, if you work this out, you end up with 0. And if the expected gain, we talked about this, and we said if the expected gain is 0, the game is fair. So the game is fair. You can recommend it. That's a good game.